Okay, so this week we want to work on correlation a little bit. And so what we're going to do is just look at different data sets. And so look how we produce this. All right, so here we are. And in this first data set, we just said, well, we're going to have a slope of 2, but then we're going to have a little wobble in it by adding somewhere between -2 and 2. So we look at our data, and so especially like you look at a bigger one like 19. Okay? So look at 19, and you say, oh, for 19, this is, sorry, I can't really point with the mouse. It's not working very well. The wolfram types do stuff. So 19 went to 38 and a little bit. 20 went to 40 minus something. 21 went to 42 plus something. 22 went to 44 plus 1 point something. 23 went to 46 minus 1.6. So we put that wobble in, and then we look at the line and we say, it is still a very strong trend line. So what we're trying to get a sense for is what happened is, does correlation care about little variations? And we look at the correlation and look at that. So a perfect correlation is 1, and you get 97. So I did a list plot, and then I did correlation on the data pairs. So I assigned the data to a variable data pairs and got it. Okay. So now we say, well, okay, but what if instead of just adding or subtracting something, let's multiply by something between -2 and 2. Oh, sorry. So what he did here is we multiply by -2. So we're doing the exact same thing, but with -2. Okay, with -2. And when we do that, and we look at our data pairs, we get a line going down. All right. So I just wanted to show you. So here's a very strong correlation, but negative. So we're close to -1 here. Now let's see what happens if we do a bigger wobble. So we have a general times 2, but then we do plus or minus 20. Okay. So we get a much bigger, so the list plot shows you there's much greater variation. Does it change the correlation very much? Not that much, right? 0.92. So it still says there's a really strong relationship. So your data can be above and below the line quite a bit, but as long as it's tending up, you can see that you get a nice strong correlation. It says, I think that there's a relationship. We couldn't hide it with that variation. Okay. So now we say, yeah, but what if we multiply by a number between 2 and 10? Okay, and so instead of having a base of multiplying by 2 and adding and subtracting, we do that. So now we get this really vast difference, right? So you can see that you're multiplying between 2 and 10. So you get really big variation. And still, the correlation is above 0.8. It's 0.82. And then just to remind ourselves, what if you just multiply by 2? If you just multiply by 2, then you get, a y equals mx kind of line. And what do you think the correlation is for that? And it is 1. So we're going to work on that in our exercises. So there's what you need. You need to set up a variable. If that's not, remember, you need to say equals and then the variable. Okay. So look what we're doing. So you're going to do something where you're doing times a constant plus a random real or a random integer if you want. Okay? And then you're going to try it where instead of and you're going to do a couple of different random real plus or minus 2, random real plus or minus 20 is what I did. And then you're going to say, instead of that, I want to multiply, instead of just always multiply by 2 and adding or subtracting something, I'm going to multiply by something between 2 and 10 and see what happens. Okay? And those are the ones that you have here. Okay? So we're going to do that, so I want to get you to get a sense of this correlation a little bit better than what we have so far.